Hello guys, today we are going to discuss about oxidation number of an element. Okay, means what is oxidation number of an element? What does it represent? Okay, we shall discuss today in this video. Along with that, we shall also discuss how to calculate oxidation number of an element. Okay, actually there are some rules which help us to calculate oxidation number of an element. Okay, so we shall also discuss the rules one by one in this video. Okay, and we shall know how to calculate oxidation number of an element. Okay, so let us start. Before that, if you are new on my channel, then please subscribe my channel and press the bell icon so that you will get notification when I shall upload my new video. Okay, so let us begin the video. Now see what is oxidation number. Oxidation number of an element is defined as the actual charge associated with an atom in a combined state or in a free state are called oxidation number. Okay, so as I have already told you, the oxidation number is nothing but the charge of the species. Okay, whatever the charge of the species or the atom, that will be the oxidation number. Okay, so oxidation number is nothing but the charge of the atom. Okay, so let me take one example. Suppose oxidation number of iron atom, that is Fe in iron 2 plus. Okay, so we have to find the oxidation number of this atom Fe. Okay, so here you see the oxidation number of this atom will be plus 2 because the charge of this atom is plus 2. Okay, so we know whatever the charge of the atom, that will be the oxidation number. So here the charge of the atom is plus 2, so that plus 2 will be the oxidation number of this atom. Okay, so oxidation number of Fe in this ion will be plus 2. Okay, so similarly if we take oxidation number of oxygen in O di negative, so here similarly because the charge of this oxygen is minus 2, so obviously the oxidation number of oxygen will be minus 2. Okay, so this is the oxidation number. Okay, clear? So now come to the rules, how we shall calculate oxidation number. Okay, so now you see the rules. So you see rules for calculating oxidation number. Okay, so now we shall discuss the rules how to calculate oxidation number of an atom in an ion or a molecule. Okay, we shall discuss one by one the rules. So number one rule is oxidation number of all element in free state or in homoatomic molecule is taken to be 0. That is, you have to know first what is free state and what is homoatomic molecule. Free state means the atom which has no charge, that atom will be called is in free state. Okay, so an homoatomic molecule means same kind of two atom combined together to form molecule, that molecule will be called homoatomic molecule. Okay, you see this oxygen, here same kind of two atom, that is oxygen combine together and form a molecule or two molecule. Okay, so this is called homoatomic molecule. And you see this sodium and iron, this atom do not have any charge, so this atom are in free state. Okay, so if the atom are in free state, okay, then that atom or that element will have zero oxidation number. Okay, and also the homoatomic molecule will have also oxidation number 0. Okay, so this is the rule number 1. Now come to the rule number 2. Okay, rule number 2 is that the oxidation number of a monoatomic ion is the same as the charge on it. Okay, so monoatomic ion means, you have to know first, monoatomic ion means only one atom and that atom should have charge, then only that atom will be called monoatomic ion. You see this one, sodium positive, this one atom, single atom, and this sodium has +1 charge, so this will be called monoatomic ion. Okay, so in case of monoatomic ion, the oxidation number will be same as the charge on it. Okay, so you see here this monoatomic ion, charge of this monoatomic ion is +1, so oxidation number will be +1. Okay, and similarly you see the oxidation number of this monoatomic ion is +2, so oxidation number is +2. Similarly, the oxidation number of this monoatomic ion -1, so oxidation number will be -1. Okay, and similarly this one -3. Okay, this is the rule number 2. Now come to the rule number 3. Now see the rule number 3. Oxidation number of hydrogen is +1 when combined with non-metals. Okay, and is -1 when combined with metals. That is, when oxygen combined with non-metals, then the oxidation number of hydrogen will be +1, and when hydrogen combined with metals, then the oxidation number of hydrogen will be -1. Okay, so now you see the example. Oxidation number of hydrogen in H2S is +1, because here in this case this sulfur is non-metals and hydrogen combined with non-metals, so in this case the oxidation number of hydrogen will be +1. Okay, and you see oxidation number of H2O, oxygen is also non-metals. Okay, so in this case also hydrogen is combined with non-metals, so in this case also the oxidation number of hydrogen will be +1. Okay, now you see this one, oxidation number of hydrogen in NaH is sodium hydride is -1. Here the oxidation number of hydrogen is -1 because this hydrogen in this case is combined with metals, because sodium is metals. Okay, when hydrogen is combined with metals, then the oxidation number of hydrogen in that case will be -1. Okay, so similarly this one also, calcium is metals, so in this case also the oxidation number of hydrogen will be -1. Okay, so this is the rule number 3. Okay, so now come to the rule number 4. So rule number 4 is that the oxidation number of oxygen is -2 in most of its compound, except in peroxide like H2O2, BaO2, etc., where it is -1. That is, the oxidation number of oxygen we shall take -2 in most of its compound. Okay, and if oxygen is present as peroxide, then the oxidation number of oxygen we shall take -1. Okay, and generally we shall take -2 in most of its compound. Okay, so this is the rule number 4. Now come to the rule number 5. Rule number 5 is that oxidation number of group 1 element, that is lithium, sodium, potassium, rubidium, cesium, etc. and group 2 element, that is beryllium, magnesium, calcium, strontium, barium, etc. are +1 and +2 respectively in all of their compound. Okay, that is the oxidation number of group 1 element, that is for these elements is +1, and the oxidation number of group 2 element, that is for this element is +2. Okay, in all of their compounds. Okay, so you see the example, oxidation number of potassium in KCl. So in this case, here this is group 1 element, so potassium is group 1 element, so in this case the oxidation number of potassium will be +1. Okay, and you see this example, oxidation number of calcium in CaO2 is +2. Here calcium is group 2 element, so in this case the oxidation number of calcium will be +2. Okay, so this is the rule number 5. Now come to the rule number 6. Rule number 6 is that the oxidation number of halogens, that is fluorine, chlorine, bromine, iodine, is always -1 in metal halides such as Kf, Al3, AlCl3, MgBr2, CdI2, etc. Okay, that is when halogens are combined with metals, then in that case the oxidation number of halogen will be -1. Okay, for example this one, if we take this one Kf, so oxidation number of fluorine, that is halogen in Kf in this molecule will be -1. Okay, so the oxidation number of fluorine in this case -1. Okay, so in this case if we take this molecule, then in this case the oxidation number of chlorine will be -1. Okay, so this is the rule number 6. Okay, so rule number 7 is that nitrogen is given an oxidation number of -3 when it is bonded to less electronegative atoms such as in NH3 and Ni3, but is given an oxidation number of +3 when it is bonded to more electronegative atoms such as in NF3. That is, when nitrogen is bonded to less electronegative atom, then in that case the oxidation number of nitrogen will be -3. Okay, and when nitrogen will be bonded to more electronegative atoms, then in that case the oxidation number of nitrogen will be +3. Okay, that is, if we take example, the oxidation number of nitrogen in NH3, if we take this molecule, so in this case this hydrogen is less electronegative. Okay, so in this case nitrogen is bonded to less electronegative atom, so in this case the oxidation number of nitrogen will be -3. Okay, and if the nitrogen is bonded to more electronegative atom, then the oxidation number of nitrogen will be +3. Okay, so you see, if we take this one NF3, oxidation number of nitrogen in NF3, you see here fluorine is more electronegative atom, so nitrogen is bonded to more electronegative atom in this case, so in this case the oxidation number of nitrogen will be +3. Okay, so this is the rule number 7. Now we shall discuss how to calculate oxidation number of an element or of an atom in an ion or in a molecule. Okay, so now let us take example. Now you see the question, calculate oxidation number to the underlying elements in each of the following species, that is in this species you have to find the oxidation number of phosphorus. Okay, so here underlying element is phosphorus, so we have to find the oxidation number of phosphorus in this species, okay, or in this molecule. Okay, so because we don't know the oxidation number of phosphorus, so we shall let the oxidation number of phosphorus is X. Okay, so first let the oxidation number of phosphorus in this element is X. Okay, now you see, okay, so the oxidation number of sodium, you know, the oxidation number of sodium is +1 because we have got the oxidation number of sodium is +1 according to rule number 5. You see this one, the oxidation number of group 1 element, that is lithium, sodium, potassium, rubidium, cesium, etc. are +1. Okay, so here the sodium atom is group 1 element, so the oxidation number of sodium will be +1. Okay, so again you see the number of sodium atom in this molecule is 1, so we have to first write 1 into the oxidation number of sodium is +1, so we have to multiply by +1. Okay, now you see next atom is hydrogen. Okay, so we have got the oxidation number of hydrogen is +1. You see this one, rule number 3. According to rule number 3, oxidation number of hydrogen is +1. Okay, we shall take the oxidation number of hydrogen +1 in this case, because in this case the hydrogen is bonded to phosphorus atom. Okay, so when hydrogen is bonded to non-metals, then the oxidation number of hydrogen is +1. You see, when combined with non-metals, then we have to take oxidation number of hydrogen is +1. So we shall take oxidation number of hydrogen in this case is +1. Okay, now you see how many hydrogen atom is present in this molecule. 2 hydrogen atom, so we have to write +2. This 2 is number of hydrogen atom, multiply by the oxidation number of hydrogen +1. Okay, again you see the oxidation number of phosphorus is X, we have let. Okay, so plus X. Okay, now you see we have to write the oxidation number for this oxygen atom. Okay, so here you see the oxidation number of oxygen is -2 according to rule number 4. You see the oxidation number of oxygen is -2 in most of its compounds. Okay, so in this molecule the oxidation number of oxygen will be -2. Okay, so plus 4, this 4 is number of oxygen atom. Here 4 oxygen atom is present, so we have to write here 4 multiply by -2 because the oxidation number of each oxygen atom is -2. Okay, now you see the sum of all the oxidation number of all these atoms in this molecule is equal to 0. That is, this sum of the oxidation number of all these atoms is equal to 0. Okay, now we have to simplify this and we have to find the oxidation number of phosphorus, that is we have to find the value of X, then we shall get the oxidation number of phosphorus in this molecule. Okay, so if we simplify this, then this will be +1. Okay, and this will be plus 2 and plus x, this will be minus 8, okay, equal to 0. Then implies 3 plus x minus 8 equal to 0. Then x minus 5 equal to 0. Then x equal to plus 5, okay. So we have got the value of x is plus 5. So oxidation number of phosphorus in this molecule is plus 5, okay, plus 5. Okay, now let us take another example. You see this molecule. Here the underlying element is sulfur S. So we have to find the oxidation number of this element. Okay. So since we don't know the oxidation number of sulfur, so we have to let. Okay. So let the oxidation number of sulfur in this molecule be x. Okay. Now, so the oxidation number of sodium is plus 1 because sodium is group 1 element. We know the group 1 element for oxidation number for group 1 element is plus 1. So here 1 multiply by plus 1. Here this one is number of sodium atom. Here number of sodium atom is 1, and this plus 1 is oxidation number of each sodium atom. Okay. Then plus the oxidation number of hydrogen. We know oxidation number of hydrogen is also plus 1. So 1 multiplied by plus 1. Here also the number of hydrogen atom is 1. So we have written here 1 and then multiply by plus 1. Okay. Then plus we have to write the oxidation number of sulfur. So oxidation number of sulfur is x. We have let, so x plus, again we have to write the oxidation number of this oxygen atom. Here you see the 4 number of oxygen atom is present, so we have to write 4 multiply by oxidation number of each oxygen atom. So here we know the oxidation number of oxygen atom is minus 2. Okay. So equal to 0 because we know the sum of oxidation number of all the atoms present in this molecule is equal to 0. Okay. Now if we simplify this, and this plus 1, this plus 1 plus x minus 8 equal to 0. Okay. So 2 plus x minus 8 equal to 0. Then x minus 6 equal to 0. Then x equal to plus 6. Okay. So the value of x is plus 6. So the oxidation number of sulfur in this molecule is plus 6. Okay. So in this way you can find oxidation number of any element in an ion or a molecule. Okay. I think oxidation number is clear, and also the technique how to calculate oxidation number. Okay. So see you on my next video. Thank you for watching.